Today we'll solve 3 important miscellaneous exercise questions from the chapter on permutations and combinations. These questions combine multiple concepts, so understanding the logic is much more important than memorizing formulas. Let's begin with question 3. A committee of 7 members has to be formed from 9 boys and 4 girls. We need to find the number of committees under different conditions. The first case is exactly 3 girls. If 3 girls are selected, the remaining 4 members must be boys. The number of ways is 4 combination 3 multiplied by 9 combination 4. 4 combination 3 equals 4 and 9 combination 4 equals 126. So the total number of committees is 4 multiplied by 126, which is 504. Now consider the second case, at least 3 girls. This means the committee can contain either 3 girls or 4 girls. We already know the number of committees with exactly 3 girls is 504. Now calculate the case with exactly 4 girls. All 4 girls must be selected, and the remaining 3 members are chosen from 9 boys. This gives 4 combination 4 multiplied by 9 combination 3. 4 combination 4 is 1 and 9 combination 3 is 84. So this case gives 84 committees. Adding both cases, the answer becomes 504 plus 84, which is 588. Now for the third case, at most 3 girls. Instead of calculating 0, 1, 2, and 3 girls separately, we use the complement method. First, calculate the total number of committees. 7 members can be selected from 13 people in 13 combination 7 ways, which is 1716. Now subtract the only committee that is not allowed, where all 4 girls are selected. That case has already been counted as 84 committees. So the required answer is 1716 minus 84, which equals 1632. Notice how the complement method saves both time and calculations. Now let's solve question 4. The word is examination. We have to find how many words appear before the first word beginning with the letter E in dictionary order. First, observe that the repeated letters are A, I, and N, each appearing twice. All other letters appear once. In dictionary order, only the letter A comes before E. So every arrangement beginning with A will appear before every arrangement beginning with A. Fix A as the first letter. Now 10 letters remain. These consist of 1 A, 2 I's, 2 N's, and 5 distinct letters. The number of distinct arrangements is 10 factorial divided by 2 factorial multiplied by 2 factorial multiplied by 2 factorial. 10 factorial is 3,628,800. Dividing by 8 gives 453,600. So there are 453,600 words before the first word beginning with E. This question teaches a very useful shortcut. In dictionary order problems, instead of listing words, count the arrangements beginning with letters that come before the required starting letter. Then arrange the remaining letters carefully, taking repeated letters into account. This simple idea appears frequently in board exams as well as competitive examinations.